Hello everyone. Here we are going to see a subject Software Engineering Practice Unit 3. The topic is Refactoring Technique. I am Franjitaras from CAC department. Why we are using refactoring? Refactoring is a change made to the internal structure of a software to make it easier to understand, and it may be cheaper to modify without changing its observable behavior. In a computer programming and software design, code refactoring is a process of restructuring existing computer code, changing the factoring without changing its external behavior. Refactoring is a disciplined technique for restricting an existing body of a code, altering its internal structure without changing its external behavior. Its heart is a series of small behavior preserving transformation. Each transformation does a little, but a sequence of these transformations may be produce a significant restricting. And then here we are going to see an advantage. You need to perform code refactoring in small steps, many tiny changes in your program. Each of a small changes makes your code slightly better and leaves the application in a working state. Do not create any features or functionality during the refactoring process. You should refactor the code before adding an updates or new features in your existing code. Then refactoring process can affect the testing outcomes, so it's good to your QA and testing team involved in a refactoring process. You need to accept that you won't be fully satisfied with your code. Your refactored code will be outdated in near future and you'll have to refactor it again. And then what techniques can you use to refactor? Here we are going to see several techniques like red-green refactoring, refactoring by abstraction, composing method, simplifying method, moving features between objects, preparatory refactoring, user interface refactoring. First is red-green refactoring. Red-green is the most popular, widely used code refactoring technique in the agile software development. This technique follows the test-first approach to design and implementation. This lays the foundation for all forms of refactoring. Developers take initiative for the refactoring into the test-driven development cycle, and it is performed into the three distinct steps that is explained in the diagram, which is green, write just enough code to pass test, and then refactor, optimize, clean up without adding new functionality and with confidence. And then red is a write failing test. And then the third steps, you focus on improving and enhancing your code, keeping your test green. Second is refactoring by abstraction. Mainly we use this technique to reduce the redundancy in our code. Branching by abstraction is a method used primarily when there is a large amount of refactoring to be done. And then abstraction involves a class inheritance, hierarchy, and extraction. The goal of abstraction is to reduce unnecessary duplication in software code. And then here is some diagram, which is a client code, and client code is going to an abstraction layer, which is a pull-up method is the best example for this approach. What is the pull-up method? Pull-up method, it pulls code parts into a superclass and helps in the elimination of a code duplication. And then what is a push-down method? It takes the code part from a superclass and moves it down into the subclass. Encapsulated field. We force the code to access the field with a getter and setter methods. And then generalized type. We create more general types to allow code sharing, replace type checking code with a state, replace conditional with a polymorphism, etc. And then third method is a composing method. Here the composing method is the most usually in these cases because in this approach we use streamlined methods to reduce duplication in our code. Some examples are extract method, extract a variable, inline temp, replace temp with a query. And then we are explaining here extraction and inline. We break the code into smaller chunks to find and extract fragmentation. After that, we create a separate methods for these chunks, and then it is replaced with a call to this new method. And then inline is a method which is an unnecessary method in our program. We find all calls to the methods and then we replace all of them with the content of the method. After that, we delete the method from our program. And then fourth is a simplifying method. Here, simplifying method is a condition expression refactoring. Condition statement is a programming becomes a more logical and complicated over time. And then a simplifying method called refactoring is an easier and simpler to understand. Fifth is the moving features between objects. In this technique, we create new class and we move the functionality safely between old and a new class. I mean, we are moving a functionality between a old and a new class, and we hide the implementation details from the public access. When you find that a class had so many responsibilities and too much thing is going on, or when you find that a class is unnecessary and doing nothing is an application. Examples are move a field, extract class, move method, inline class, hide delegate, introduce a foreign method, remove middleman, introduce local extension, etc. Sixth is preparatory refactoring. This approach is best to use when you notice the need for refactoring while adding some new features in an application. You save yourself with the future technical debt if you notice that the code needs to be updated during the earlier phases of a feature development. And then here is a diagram for the preparatory refactoring road, that is a start from the destination. Seventh is a user interface refactoring. You can make simple changes in a UI and a refactor code. Example is align entry field, apply font, reword, inactive, voice, indicate the format, apply common button size and increase color contrast, etc. Why is refactoring important and what are the benefits is explained here. That is, first of all, it is used to promote maintainability and scalability. Development teams admit that software maintenance is painstakingly difficult when the code is unstructured, poorly supported, and then enhance readability. Even seasoned programs find it challenging to read and interpret the fluffy code in applications that are yet to be refactored. Thank you.